Okay, so let us discuss the doubts. You can tell your doubts. We are going to discuss question number 8. So, first I will explain what is the question number 8. Electric fan has blades of length. If there is a fan, let us say these are blades of the fan, like this. Blades are there. Okay, and this blade of the fan has length. So that means this length is given, this total length, and they have given as 30 centimeter, means 0.3 meter it is. Okay, as measured from axis. If the fan is rotating, the rotational speed omega of the fan they have given 1200. Definitely what they have given is frequency. We should note that 1200 rpm they have given. So rpm is frequency, omega is 2 pi into frequency, that we know that. So this we can first calculate into SI unit. So 1200 revolution per minute it is. So you must convert the first frequency into RPS. 1200 revolution 1 minute is 60 seconds. So that becomes 20 RPS, or it is called Hertz also, right? So once you calculate this, after that, first let us do what they are telling in the question, and then we can do calculation. So frequency we calculated, omega then we can calculate, because 2 pi into frequency is 20. So omega will become as 40 pi. Of course, its unit is radian per second. Okay. So now the question is acceleration of a point on the tip of the blade. So first of all, tip of the blade means any this one, or any of these points, right? So first of all, tell me that these points are rotating in a circle, right? Each point will rotate in a circle. So these points are also rotating in a circle. Now, first of all, tell me, is the speed constant or not? Did they say that the speed is changing or is speed constant? What did they say? Acceleration. Hmm. Acceleration. So in a circular motion, no, in a circular motion, there are two type of means. If there is a uniform circular motion, then only centripetal acceleration you have to calculate. If the speed is also changing, then there is a tangential acceleration also. Then we have to calculate resultant acceleration. So first you tell me, apply your common logic and tell me what type of circular motion it is. Is it a uniform circular motion, or is it a means a non-uniform circular motion? Tell me. That means you know that you need to only calculate centripetal acceleration. Then, so centripetal acceleration formula, you know, it is here omega we are calculating, so you can use omega square into radius. That's all. So omega and radius means this length is the radius here. Okay. Then you calculate. So 40 pi whole square into radius is 0.3. Now 40 square becomes 1600, pi square comes 0.3. And note here that pi square is approximately equal to 10. In many calculations, we can take pi square approximately as 10. So if you take this as 10, so 1600, this will become 10 and this will become 0.3. So 0.3 into 10 will give 3. So 1600 into 3 is nearly we are taking nearly 4800. Okay, radian, sorry, meter per second square, right? So this is approximately the answer. Then you can choose. That means second option you can choose, right? Okay. Then any other doubts? Any other doubts you have on this question number 17? Okay. Okay. And question number 17. Okay, let us see that. In the given figure, in the given figure, This is particle. Acceleration means, of course, when they say acceleration means it is resultant acceleration. So this they have also shown. This is the acceleration, and this is the center they have shown, and this is the radius, of course, and it is given that this angle is 30 degree, right? They have given, right, Philip? Radius is charge here. Radius value they have given us 2.5 meter. This acceleration is, of course, the resultant acceleration, which is they have given 15 meter per second square. Okay, then what they are asking is the speed they are asking. So right now, what is the speed? That means right now, of course, it is going in this way. They have also shown that anti-clockwise like this. So at this point, this velocity vector will be in this direction, tangential. Now tell me what is the doubt in this? What is the doubt? I want to understand your doubt. No, no, not first you understand question. If you understand question properly, then automatically you will know. You don't have to think what formula. Formula automatically will come. Okay. So see anything. How do you know what to which formula? What is given in the question? Understand properly. Then what we need to calculate? Understand that also. When you know this what is given, what to find, then you will bridge the gap between them by your thinking power. You will do that. So see here what is given, there is a circle is given, there is no complexity, it's a circle is given. In that circle, radius is given and total means net acceleration is given, and it is given like it is going like this way. Okay. So now first of all tell me, in a circular motion what are the two type of acceleration? Draw that. Draw here. You can draw it. So draw this. So centripetal will be toward the center, and towards center, and radius, and tangent. Of course, it is going like this way. So velocity is this way. So tangential will be also like this way, right? Ah, that means this is like AC, and this is like, and they are always 90 degree. Yes, they are always 90 degree. Right? And their resultant is what? What is their resultant? What is some? That is A. That is what is A. Now, what is given? What is this angle 30 degree? It is it is the angle between this. That means if this A is given here as 15, can you not calculate AC? Can you not calculate 80? Ah, tell me what is AC? Tell me what is AC? Ah, correct. A is 15 and cos is root 3 by 2. Ah, okay. 80 also if you want, what it will be? 80? A sine 30 degree, correct. That means 15 into half, right? 15 by 2 is right. Okay, now tell me speed. I want to calculate speed. Remember, I have to calculate speed. So now tell me what should I do? I know centripetal, I know tangential. How to calculate speed? This question you will only solve, but you tell me how can you calculate speed if you know centripetal acceleration, tangential acceleration? You know radius, you know centripetal acceleration, you know tangential acceleration. How to calculate speed now? But omega we don't want. We want speed. Over na. Over. That is what it is. This is v square by r and r is given already. R is 2.5. So from here v square is equal to r into this 15 root 3 by 2. Now v square is r is 2.5. 2.5 into 15 root 3 by 2. Now we need to simplify that. So do calculation now. So v will be under root of this 2.5 into 15 into root 3 by 2. Now check the calculation and match the answer. Maybe calculation is some little calculation may be there, and we have to now check answer. So what are the possible answers? 5.7, 6.25. Okay. So this how do we solve now? This now calculation only. Approximately, let us try to do some approximate calculation. So this I can write as 5 by 2, 2.5. This 15 root 3 by 2. Now this 2 I will take outside, and 15 into 5 is 75. In that 25, I will take 5 also out. So I will get 3 root 3 inside. Right. So now try to find out what it will be. Okay. Try to do the calculations of this. Hmm. Can you calculate? So speed is equal to 5 by 2 root under root 3 is nearly 1 point, sorry, 1.732. It is 1.732. So 5 by 2 root under, let us calculate this. 9, 7, 3, 3, 1. Nearly this it is. Suppose it is nearly 5. Okay, let us say nearly 5. So nearly 5, approximately it is nearly 2.3 something comes out. Okay. So if I take nearly that, then suppose if I remove this term, 7, so 23, so 5 point something will come. Okay. So you can go with that option. Yeah, you can go with that answer. Right. Then anybody having any doubts, ask question. One minute. Question number 22. Object is projected from ground with a speed v centimeter. The centripetal acceleration 1 second after the projection. Okay, let's discuss. Question number 22. So an object is there. This object is projected with a speed of 20 meters per second. Okay, at an angle of 30 degree. So this object, it is going to have a projectile motion like this. Okay. Projectile motion will have this is the ground. Right, for this much. Okay, so question is its centripetal acceleration in 1 second after the projection. So after 1 second, first you have to find where it goes. Okay, where it goes after. So you know the component of velocity. Resolve this u cos 30 degree. Okay, so how much this will be? 20 cos 30 degree means root 3 by 2. So that becomes tan root 3. Okay, and here 20 sine 30 degree, that becomes 10. Okay, so you know that any point, if you consider its horizontal ux never changes, right? And this is uy. Vertical component decreases or vertical component only changes, right? Horizontal component of speed velocity does not change, right? So now let us try to calculate 1 second. After 1 second, what is the velocity? Okay, so horizontal component will not change, it will remain same as tan root 3. Only the vertical component you try to calculate, and you can use v equal to u minus gt. This formula you use because vertical velocity component you use. So let us calculate vertical. So initial component was 10 minus g is also almost 10 time is 1. So you can see that this is going to be 0, right? So vertical component is 0. That means it will be at the topmost point, correct? So it will be at the topmost point, only horizontal component remains. Vertical component is 0. That's what it is. Okay, now they are saying what is centripetal acceleration. So whenever they talk of centripetal acceleration means you need to think that there is a circular motion happening, right? Although the body is not going in a circular motion, but we have to assume that there is circular motion means you have to study the instantaneous circle. Instantaneous circle. So you try to draw a instantaneous circle here. Here try to draw a instantaneous circle. Now in this instantaneous circle, we have to keep this as velocity. This is like the velocity right now. This is the velocity. Now we know center of the circle is here. This circle center will be here, and the velocity is always along tangent, and this acceleration must be centripetal means it will be like this way. Correct. This is the centripetal acceleration. So now if you see at this instant, this body, the acceleration due to gravity is acting like this way, and this is the velocity which is tan root 3, right? This is the velocity. So now this acceleration which is perpendicular to velocity, that acceleration is what is the centripetal acceleration. Over now, the answer is 10, right? But now the question is, suppose if they would have asked at any other time, let us say they asked at uh, 0.5 second or somewhere, anywhere, let us say when it comes here, they ask at this point. At this point, you need to think of this velocity like this, and there may be some horizontal, vertical, all that, but some velocity will be there. That velocity you need to calculate first. How will you calculate? You will calculate the vertical Vy. U component does not change. So Vy you will calculate and then you can take resultant, right? That you can do. Now, suppose they ask what will be acceleration there. So we know that the acceleration due to gravity is always vertical only. It is acting this way only. But if they are centripetal means you need to draw an instantaneous circle. So try to draw an instantaneous circle by keeping velocity as tangent. Remember that instantaneous velocity you have to keep as tangent. So if you draw a circle, it may come somewhere like this, and its center may come somewhere here. Correct? It will come somewhere here. Now, if they are centripetal acceleration, you need to first find out how much this line, which is the radius line, makes angle, let us say alpha, with this acceleration g. How much it makes. That alpha you have to find out somehow. And once you find that alpha, then g you have to take in this direction, component of g you have to take, and that component of g in this direction will be g cos alpha, right? And the component of this direction will be g sine alpha, correct? G you can resolve. Hmm. Yes, sir. Because see, whenever you, because velocity when you take, based on the velocity only we will define which side is the center. We cannot take horizontal and vertical. Velocity means actual velocity of the particle. Okay. So based on the velocity, you have to find out where will be the center of the circle. Center must be like this way because radius and velocity has to be perpendicular, right? That, that's how you will calculate alpha. How will you know what is alpha? Alpha calculation will come when you draw this diagram and g is downward. Now, then you will be able to calculate alpha. I will give example, but first know that alpha you need to calculate, and alpha calculation will require that velocity v. Once you calculate alpha, g cos alpha is the component of acceleration toward the center. So g cos alpha is the centripetal acceleration, right? This is centripetal acceleration. And this centripetal acceleration can be now written as v square by radius. This radius is called radius of curvature. You know that instantaneous radius of curvature you have calculated also. So this is the instantaneous radius of curvature, and this is g cos alpha. Anyway, here what they are asking, here of course fortunately here it was total g was there, so that's all. But in case if some angle is coming, then acceleration centripetal will be g cos alpha, then your answer will be g cos alpha. That is the answer. But sometimes they may ask you to calculate radius of curvature, then in that case radius of curvature you have to calculate like this way as v square by g cos alpha. Okay, this radius of curvature we can calculate. This is radius of curvature. Radius of curvature. Now let's take example. Take same question and let us take 0.5 second. Take 0.5 second and find out velocities. So horizontal velocity never changes, that is tan root 3 only. Vertical velocity let us calculate, v is equal to u minus gt. Calculate initial velocity in vertical was 10 minus this 10, but time is half, even 0.5 seconds. So this will become 5 then, right? This will be 5. Right. This is going to be 5. So now let us try to figure out what will be the resultant velocity, because we know the trajectory will be like this, and somewhere it will be here only. Okay, somewhere it will be here, and this velocity will be, so means directional velocity will be like this way, correct? This is the velocity, this will be x component, y component will be like this, but g will be like this, acceleration due to gravity will be like this. So we need to try to find out means uh, component of g. So remember, centripetal acceleration means the component of g must be perpendicular to velocity, because centripetal acceleration is perpendicular to velocity, right? So we need a line like this way, and this angle is what we need here. Then only we can find the component of g. So center will be somewhere here in this circle. Center will be somewhere here. Okay, somewhere on this line, the center will be there. So how do we now calculate this angle alpha? That is what now we have to think about it. Hmm. Yeah. Hmm. This is the line, and this line is the vertical line. Okay. And this line is anyway 90 degrees. Okay. This is 90 degrees. So this, suppose this angle is alpha. Okay. This angle is alpha. So this is 90 degrees. So this must be 90 minus alpha, correct? Because total angle is 180 degrees. Are you understanding this? Straight line this is. So total sum must be 180 degrees. So this is alpha, this is 90. This must be 90 minus alpha, correct? Right? This must be 90 minus alpha. And suppose if I draw a horizontal line here. Suppose if I draw a horizontal line here. Horizontal line here. So horizontal and vertical makes total 90 degrees. So this is 90 minus alpha means this must be alpha only. Correct? That must be alpha. That means V is making angle alpha with V. That alpha only we need. Now you have already calculated this, right? You have calculated this as 5 and this is tan root 3. So if you draw the resultant, that is the velocity, right? And this is what is alpha. Now you can calculate now alpha. Everything can be now calculated from this triangle, because this is tan root 3 and this is 5. You make this triangle. This is the velocity. This is alpha. So this is same as 5. Right. So we can calculate sin alpha formally, because this triangle hypotenuse we can calculate. Right. What will be this v? This will be root under 5 square plus 10 root 3 whole square. Okay. Calculate that. So 25 plus this is 300. Na? 300. Yes, root 325. So this hypotenuse will be root 325, and sine alpha will be now how much? Sine alpha will be 5 by root 325. Now you got na sin alpha. So now you can take component of g in this direction. So this component of g in this direction is g sin alpha, and this is the centripetal acceleration, right? So g is 10. Let us take g as 10, and sin alpha we have calculated 5 by root under 325. This is the centripetal acceleration at 0.5 second. This is the time when 0.5 second. Clear? Yes. So any type of question. Huh? What? Because this component of acceleration, this is the resultant acceleration of a body. Again, come back to circle. Okay, circular motion. You know, in circular motion there are two type of acceleration: centripetal and tangential. Yes, right? And their resultant. Just now, one question we solved. How did we do that? The first question that Akhil asked, that one was saying that is complex, right? But that is what it is. So this acceleration is the acceleration ag here, and this is the angle alpha. That cos component that is toward the center, that is centripetal, and this is along tangent, that is tangential. You understanding this? Yes. See, what is alpha actually? What is alpha? Anywhere you take alpha, in this case, what is alpha? Alpha is the angle made by this velocity with the horizontal, right? That angle alpha is the same angle with the acceleration, which means in this projectile motion, that angle alpha is the same angle with this g will make with that. Take anywhere. Suppose you take a, yeah, take anywhere. Suppose you take anywhere. It is not that only that one. Suppose you take any general case. Here you take. Here g is acting like this way. G means the total acceleration, net acceleration. Okay, and the velocity, let us say it is like this direction. This is the velocity direction. Ah, so tangential will be in the same way. Now here we need to think of a perpendicular, right? This is the perpendicular, this is radial direction. So now this is what is alpha, we need to think about it. Okay, so if this is alpha, this line of course is vertical, so this is also going to be alpha only, right? This is going to be alpha. And now if I consider here, or see, if this is alpha, this is alpha, definitely this will be 90 degree only, correct? Because this is radial line, this is tangential line. So this is yeah, this is alpha, this is so that means here if I make horizontal line, let us say I make horizontal line, so will it also make same angle alpha? Because see, this is alpha, this angle is 90 degree, so this is 90 minus alpha, and this total is also 90, so this is also, that idea is that alpha is here the same angle which velocity makes with horizontal. Are you understanding? The question is how to calculate alpha. Alpha is nothing but the angle made by the instantaneous velocity with the horizontal, and that we have calculated. See, first tell me, this is radius and this is tangent. This total angle will be 90 degree or not? And if this is alpha, this will be 90 minus alpha or not? And tell me then, what will be this total angle? No, no, no. Total angle means between this horizontal and this vertical, 90. And this is 90 minus alpha. So what should be this one? Then this is what it is. Hmm. Yeah, because this angle is 90 degree, right? And this is 90 minus alpha, so this must be alpha only. So what is the idea is that? Idea is that this radial line making angle alpha with the acceleration due to gravity, that angle is the same angle which velocity makes with the horizontal. Sometimes it may be down and sometimes it may be up. It doesn't matter. But what angle it makes with the horizontal, that is what is the alpha. Okay, that is the alpha, and that alpha is very easy to calculate because you will be always ux, this vx never changes, right? Vx ux is always same, horizontal component never changes. And vertical component we can always calculate by using uy minus gt. Time will be given, now then you will calculate always, right? You can always calculate, and once you know this triangle, then you will be able to calculate, because this is velocity, so this is alpha. You will calculate this tan alpha from this triangle. You can calculate, correct? So if you want tan alpha formula, we can write tan alpha, or if you want sin alpha, let us write sin alpha. So sin alpha formula from that triangle means this is Vy and this is V. So that is nothing but Vy by V. Vy by V, and Vy is nothing but Uy minus Gt, and V is nothing but resultant of that. So this is resultant means Vx component, which is Ux square plus this Vy square. Vy is Uy minus Gt whole square. That's what it is. So sin alpha can be calculated from this, right? So we can, once you calculate sin alpha, then you can calculate the component of G in this direction. That will be G cos alpha. That is the centripetal acceleration, right? Clear? Sorry, yeah, G cos alpha. See, I think here G cos alpha was there. There was G sin alpha. I think you check that, isn't it? Check that. Here G component, this was alpha. So this was G cos alpha. Then I think this was G sin alpha. Check that here when it was going up. That time this was alpha, right? So this was alpha. G. Did we make any mistake or what? Hey, G sin alpha or G cos alpha it is? Cos only, na? Not sin. No. This said, this is cos, na? That you so ask. This is G component, that side, na? G cos alpha it is. G cos alpha it is. So cos means what from here? Cos means tan. This will be tan root 3, na? Tan root 3. Okay, so 10, if you want take inside, so root under 300 by 325. This you can calculate, right? Root under 300 by 325 we can. So this is G cos alpha, sorry, not sin alpha. This is G cos alpha. The component of G in this direction is G cos alpha. Okay, clear? Yes. So sin alpha we don't need, we need cos alpha now. So let us calculate cos alpha. So cos alpha means we need x component. We need is ux by v, so ux by this. Okay, so we need cos alpha, we don't need sin alpha, we need cos alpha. So cos alpha like this you will calculate, right? Cos alpha like this you will calculate, and then you will find out everything whatever you want. Suppose they ask tangential acceleration, then you take G sin alpha. Okay, if they ask tangential acceleration, then you calculate G sin alpha. Then sin alpha now we can calculate from it. So sin alpha is that same way, it is Vy by V. V and Vy we can calculate from it, not a problem. Correct? Yes? Yeah, because this is the component of G along the radius, that is the component of G along the tangent. Clear? Yes? See, what is radius of curvature? Now let us calculate. You have calculated centripetal here, right? Centripetal, what you calculated, that you will use as v square by radius of curvature r. Let us say r is radius. Now let us calculate radius of curvature from here. It becomes v square by centripetal. Now v you will substitute. V you will substitute. So V already, I think we can calculate from this formula, right? V we will calculate from this. So square of this you will do. Let us substitute centripetal now. Centripetal we have calculated, which is G cos alpha. G cos alpha I will do. Okay, now let us try to find minimum radius. When which minimum radius happen? So V square by G cos alpha will be what? From that same triangle, because this triangle will be, this is Vx or Ux, and this is Vy, and this is resultant V, and this angle is alpha. Okay, so what will be cos alpha from here? Cos alpha will be ux by v, ux by v. Okay, let us try to substitute that. So it will be ux by v. So it will become vq by g into ux. Correct? Right? Now tell me, minimum radius means what? Minimum radius means g is anyway constant, ux always constant, ux does not change. Now this speed only, it is depending on speed. So radius minimum means speed is minimum. Now tell me, where is the speed minimum? In, tell me, yeah, where in the projectile motion, we are talking of projectile motion. Where is the speed minimum? When you thrown it like this, where is the speed minimum? Yeah, that's all. That's the answer. So, and what is the speed there? That speed is ux only, right? That speed is ux only. So that means the minimum radius will happen when this v becomes equal to ux. At this top point, v becomes ux. So substitute that ux cube by g into ux. Ux will get cancelled here. So ux square by 2 g comes. Ux is u cos theta. So u square cos square theta by g. That is what is the minimum radius. Clear? Yes? Okay. Then any other doubts? Then ask. Ah, yes, yes, maximum. I also explained that in the class. So suppose radius is given, of course, radius is given. Okay. Now you try to make put so many sand particles and try to make some kind of cones, and try to make some cones by taking sand particles. And let us say you have made a cone like this. After that, if you put any extra sand, it comes down. Okay, that means you cannot make more than this height. Okay, also they are asking, I think they are asking height. What is this maximum height of this cone which you can make? Right, that's the question. Now suppose you have made this maximum height, and let us say this angle is theta. Okay, this angle theta. Now suppose if you are keeping any extra sand, little bit also extra you keep, it starts sliding down, right? Now tell me at which angle things object will start sliding down. So minimum condition you take that it is the angle of repose. That angle is repose. Over, over na. Because this theta is angle of repose phi, let us say, which is nothing but tan theta must be equal to then mu. That's all. And tan theta from here is h by r mu. So h becomes equal to mu into r. That's the answer. Very simple. No, 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 no. What you will do by taking volume? Whatever volume you take, because it cannot go beyond this height. Because if it goes beyond this height, angle will increase and it will fall down. That is what it is. Okay? It is simple. It is. Then any other thing? Question number 32. A bead of mass m is at a point A comma B on a wire bent in this shape. So there is a wire of this shape of parabola. This is x-axis and this is y-axis. See the diagram. This is the center. Okay. So now suppose if I want what they are saying, there is a bead kept here. Some bead is released here from this point. Okay. Rotating. Oh, not released. Sorry. There is a point here, A comma B. This equation of parabola they have given y is equal to 4c x square. Okay, right. A bit of mass m. So this bead has a mass m here. Okay, and rotating with a, so this whole wire is rotating about this. Okay, this whole wire is spinning about this y-axis. Okay, with the angular velocity omega. So that means any point on this wire will be going a circular motion. Take this point, right? It will be going in a circular motion with center at this axis. Are you understanding this first point? Hmm. Yes. Okay, you take anti-clockwise or clockwise. It doesn't matter which direction you want. You draw that. That is not important. You draw it like this. Okay. But what idea is that any point on this, like wheel is like a point here, it will be going like a circular motion like this, and the center of that circle will be on the axis of y-axis, right? Okay, it will be going like this. Okay, then the question is the value of omega is neglect friction. So um, stage means this is not sliding down, it is not falling down, it is remaining there and it is going in a circle. That's the question, right? And we need to calculate omega from this question. Okay, and that's what it is, omega. And this point they have given, that means this distance, x distance is a, y distance is b, correct, right? And we need to find out what is omega. Now you tell me, like if it is going in a circular motion, of course it is staying, means it is going in a uniform circular motion. So if it is uniform circular motion, what is the acceleration in a uniform circular motion? Huh? Ah. In a uniform circular motion, there is only centripetal acceleration. Tangential is not there. Okay. That means the acceleration must be only in towards this center. That is what it is, right? This is the resultant acceleration. The centripetal is the only acceleration in that. Okay. Now, now think about it. So that means resultant force must be toward this center, right? Net force must be in this direction on, right? Because acceleration is this direction. Okay. Now let us resolve the forces. Draw the free body diagram. So of this bead, what are the forces acting? Mg, Mg, and note that friction is not there. Friction is not there means what is there then? Normal contact will be there now. Bead is on the wire means some normal must be there. So normal, yeah. So some normal must be there. So normal must be like this. Normal must be like this. Normal means what? Normal means if you draw a tangent on this is a wire here. Note that this is a wire. So on this wire, if I draw a tangent, this is a tangent on the wire, and this is the normal on the wire. So normal must be going like this way, perpendicular to tangent. Correct? Yes. So tangent, at this point you first draw a tangent and normal is perpendicular to that tangent. Okay, like this way we will do. Okay, then we have to resolve forces, right? Because we know resultant force is along toward the center this side. So let us resolve forces in horizontal and vertical direction. Okay, horizontal and vertical direction. Okay, but how much angle this normal will make with the vertical? That angle is the same which this tangent make with the horizontal, because this is just like an inclined plane. Yes, just like an inclined plane, no? In an inclined plane, that's what happens. It is just like inclined plane. Now resolve normal. So normal in this direction become normal cos theta, and normal in this direction become normal sin theta. So because resultant is this way, so normal cos theta will balance mg. Normal cos theta will balance mg, and normal sin theta, that is the net force, which is the centripetal force, right? Okay. So let us write that. So normal sin theta is the net force, which is the mass into centripetal acceleration, and normal cos theta is nothing but mg. So now let us take the ratio of these two things. Take ratio. When you take ratio normal sin by normal cos, mass into centripetal acceleration, mass into g, mass cancel, and cancel, tan theta comes as AC by G. AC I can write as omega square. Yes, I can write omega square into radius, and note that the radius here is nothing but this length A. Yes, this length A. Yes. So omega square into radius means A by G. Now tell me, I have got this equation, tan theta is equal to omega square A by G. I can calculate omega from here, but I do not know tan theta. Now tell me tan theta. Now you tell me tan theta. Just little bit think, you will get the idea. Hmm? No, no. What I am saying is tan theta I want. Mg by what you are saying? Mg by n sin theta. How? This one, huh? This diagram you are saying. Mg by what? Mg is equal to n cos theta. That means you are saying tan theta is equal to tan theta. See, because mg by n sin theta you are saying, but mg is n cos theta, right? So mg by n, no, no, I think you are saying cot theta. You are saying tan theta is equal to cot theta, because you are saying mg divided by n sin theta, but mg is equal to n cos theta. So n cos theta by n sin theta will be cot theta. Something different you think, because from this diagram, something is hidden in this diagram only. Something is hidden very, very. No, and sin theta by n means sin theta. And you are saying tan theta is sin theta. Think about very slight. It is the basic math. It is the, if you have studied basic math calculus, then you can tell very easily. Little bit thing. Raghu and Sanjay. Sanjay is also there now. How will you? How will you do it? Come on. Yes. Oh, if you are not able to think means you need to revise the basic maths. You know, if I will tell you, na, then you will beat your head. You will say, sir, I know this, I know this. Knee diagram, but of course in this diagram only, Okay, I give you one extra minute to think about it. Then I will tell. I want tan theta. I want value of tan theta. Then only I can calculate omega. I want to calculate omega. Remember. Oh, very good. Raghu, you have cracked this question then. Because dy by dx, this slope, now slope is tan theta over, game is over. Right? Okay. So tan d y is given now. Y is given here as 4c x square. Then dy by dx you calculate. Dy by dx is 4c x square, differentiation 2x. So that becomes 8cx. And where are we wanting? Where do we want dy by dx? We want when x is equal to a. So substitute x is equal to a, you will get that, right? So at x is equal to a, at x is equal to a, dy by dx, which is equal to tan theta, will become equal to 8cx. X is a, that means 8ca. Now so substitute here tan theta and solve omega. So 8ca is equal to omega square, a by g, a cancelled, omega square is equal to 8cg, omega is equal to root under 8cg. That is the answer. Yes. So it was not a difficult now. Omega tan theta is dy by dx slope of this, right? And root under 8 means so root 2 will come, 2 will come outside. So if you match with the option, then you take it to outside. So 2 root under 2cg. That is the answer. Okay. Then any other doubts, questions? What is the doubt? First, it is bank, right? Bank means this is the road is like this, and this object friction is there or not there. Which case are you taking? Okay. So if friction is there, then first of all you need to think which direction friction will act. Friction acts in the direction opposite of tendency of relative motion. Tendency you need to think, right? So suppose if this person is driving very high, so it may start skidding upward or sliding upward, right? So in that case, friction has to act like this way. That means he has a tendency of upward motion, upward motion. This tendency happens because he is driving with a maximum speed, right? Because he is trying to go beyond a maximum speed. So that's why he can start sliding upward. So friction will act downward. But suppose if he is not going, he is not at all trying to go, he is trying to just remain, or he is driving with a very small speed. In that case, he has a tendency to slide downward, right? He has a tendency to slide downward. Yes, tendency to slide downward, to slide downward. So in that case, friction is supposed to prevent its downward motion. So friction will act in this way. That is the main idea. After that, other things you already know. Other things is mg act downward and normal acts like this way, which is the same case here also. Mg act like this way, normal acts like this way. And note that it is going in a circular motion. So this is the circle. So net force must be towards this side, which is the centripetal. Here also is going in circular motion. So net force must be this side, which is the centripetal force. Then you resolve forces, vertical forces you balance, horizontal forces this way, that is the net force mass into centripetal acceleration, and then you can Substitute this friction because it is going to just slide, so you take it mu times normal. Similarly, here also you take this friction as mu times normal. Okay, and here this case will give the maximum speed, and here this case will give the minimum speed, right? So both speeds we can solve that, right? Clear now, because if you balance here the friction, see friction is acting like this way. So component of friction, when you take, you want horizontal and vertical component. So this angle is also theta. So this direction f cos theta happens, this direction f sin theta happens. Normal also we need to resolve it. Normal makes angle, same angle with verticals. This side normal cos theta, this side normal sin theta. So the net force which is acting here is normal sine theta plus friction cos theta. This is net force, which is mass into centripetal acceleration. And vertical direction, it is balancing. That means their normal cos theta is balancing what? It is balancing mg plus plus f sine theta. Okay. So I will take f sine theta this side. So normal cos theta minus f sine theta is equal to mg. So this is first equation, this is second equation, and we are dividing it here, and we are also substituting friction as mu time normal. So this normal I will take common from the first equation. So mu times normal, so mu cos theta it will become is equal to mass into acceleration, we will write as v square by r. Second equation also normal will take here. So this will become cos theta minus mu times sin theta is equal to mg. And now when we take the ratios, this normal will get cancelled, and this mass will get cancelled. So we will get the ratio of sine plus mu cos divided by cos minus mu sine is equal to v square by gr, right? So from here now we will calculate, we can divide by cos in the numerator and denominator here, so it becomes tan theta plus mu, and this become 1 minus mu tan theta. This is v square by gr, and already I told that mu we can take as tan phi, the pose angle, the pose. So this become tan A plus tan B, 1 minus tan A tan B. So this become tan of theta plus phi. So that is v square by gr. Correct, na? This is maximum speed. Remember, this is maximum speed. Yeah. So v maximum we will calculate from here, root under gr tan of theta plus phi. And in the case of minimum, similar way equation we will make, and minimum comes as root under gr tan of theta minus phi, right? So the speed must be between this minimum and maximum. You have to choose a speed between minimum and maximum, right? Done. So that's what it is. So done for today's today. Your doubts, I hope it is clear, right? So continue working, then we will go further in the next class. Okay, right? Okay then. Yeah. Bye bye. Yeah. Yes. Yes. Kinetic. Whenever a body is moving, we have to take kinetic friction. But if nothing is given, whatever mu is given, you take that mu as the mu, right? So if nothing is given means that mu itself you have to take. Yeah. Whenever the body just starts sliding means at time zero, just starts sliding. That time you take maximum static, but soon once it starts sliding time greater than zero, then you have to take kinetic friction. Immediately nature of friction changes. Otherwise, if it is already sliding from the beginning, then you have to take kinetic from the beginning, right? Yeah, in the question they will give conditions. Okay. Fine. Okay, then let us meet in the next class. Bye bye. Yeah. Hmm.